Welcome viewers. Today we are going to see the Tower of Hanoi problem. How we can solve the Tower of Hanoi problem. The first, what is Tower of Hanoi problem? Where we are having a tower. On the tower, we are having a disk as shown in the disk A. So here, because disk on the bottommost, and then the next level disk, and so on. We are having placed on the tower. Now the condition is one tower, one disk can move at a time, right? And also here the condition is you should not place the lower size disk below the upper size disk. This is the condition. So now how we can move the disk from tower A to C using that in between we can have now the auxiliary disk, right? So now how can we move that one in the efficient way to move the disk from A to C? So here the now what we can do now, the disk 1 move to C and then disk 2 move to B, then one here the disk 1 to B, the move disk 3 to C, then disk 1 to A, and then disk 2 to C, then the disk 1 from A to C is the way of moving. Now we can solve the problem by programming. We can write a program in the recursive function. Right? How is a recursive function? Here we are having now the towers of Kana is a function. The towers of Kana is a function where we are calling the same function within that function. So this is called recursive function. Now, in that while calling that recursive function, what it will happen here? Here it will create an activation record. The activation record is storing return address, then local variables on the stack. Local variable on the stack. Now, here you see. Now we are calling that function with this condition. So we are having calling the function with num3 disk A, B, C. Currently now the disk on the tower A, right? Now here how we can start now. So 3 ABC. So 3 here, A is from, then B is auxiliary, C is 2. Now we are calling that function. Here if n equal to 1, this condition is not satisfied. N equal to currently 3, the condition is not satisfied, then it will call that function. So tower of Kanai with here currently now that n is 3, n minus 1. So that is currently we are calling the function with the 2. Here from is A, then 2 is C, then 3 is B. Right? Now we are calling. So here before calling that one, what it will do now? So here we are calling that function. After calling, it will return to the location here L1. Right? Here suppose this function is called, it will return to here L2, right? In that L2 we are having that implied that we are having one return function here, one return, right? Then here we are before calling, it will place the current value. So current value is 3ABC. So it will place in the stack 3ABC, where we have to return now as L1 location. L1 location. Then we start now as 2ACP. This is another function. Now the another function now 3ACP. So we are calling that function with 3ACP. So here now n equal to 1. No, we currently now n equal to 2. So this is the current status. So n equal to 2. So n equal to 2. So once again it will call the same function tower of Kanai with. Now it will place the current value 2ACP. 2ACP as well as the return location is L1. Then here 2ACP is calling now. So 2ACP is placed and we are calling now as 2 minus 1 1. Then here A, C is here A, B, C. 1 ABC. We are calling the function with 1 ABC. Then 1 ABC, the condition is satisfied. Now it will write that one move disk 1 from A to C. So move disk 1 from A to C. So this is the condition. So A to C. So move disk 1 from A to C. We are moving the first system. Then after completing this one, so this is if part, then it will come to here. So it will return. So while returning back, it will pop from the stack, right? So this is the pop out. So 2 ACB. So current after return to where we have to return L1. So it will return to here with current value is 2 ACP. Current value is 2 ACP. Now what it will do now? Print the move disk N is currently 2 and from A to B. So this is the case. So here move disk 2 from A to B. So move disk 2 from A to B is moving, right? Then we are popping out from the stack. So currently now the stack is having 3 ABC with L1, right? Now after printing, now what it will do? Now it will call this one. So before calling that one, once again it will place the current value is 2 ACP. So the 2 ACP is placed. Currently now the 2 ACP is placed. 2 ACP is placed. 2 ACP is placed. Now we are having that addresses, return addresses. Now what will happen here? So this is the function call now. So this is the function call now. So here now it will call this one and this will call now n equal to 1. So here 2 ACP. So here we are having now CAP, 1 CAP with placing the stack is 2 ACP with L2. So here we are having now this one we are placing 2 ACP is pushed on the stack and currently now the return address is L2 and we are calling that function with 1 CAP. So 1 CAP this condition is satisfied, then it will print now one disk 1 from C to B. So this is the case. Move disk 1 from C to B. So this is the case we are having now. Then after completing that one, what it will happen here? So here after completing that one, it will return. So it will return. Where have to return now? You have to return. You have to return here. Return to here. This is the case. Now this is in intent return once again to L2. So in that L2 nothing is there. So it will return here once again it will return, it will pop out that is 3 ABC. So 3 ABC is written. Now return where L1. So because of this one L1, so it will return to 3 ABC. So here we are returning at with the value of 3 ABC. Now 3 ABC is print now. Print move disk 3 from A to C. So move disk 3 from A to C. So this is printing now. So now what we have to do is move disk 3 from A to C. We are moving now. Right? After completing that one, then once again we are calling that function with here. Now we are placing the current value is 3 ABC. Now what we are having now? What we are having now in the stack. Right? So here now that current stack value is we are calling that function with now current stack is 3 A, B, C, but return address is L2 because 3 A, B, C is calling here. So return address is L2 and now what you are calling now the N 3 is currently now that value is 2, then ACP. So here we are going PAC to PAC. So this one 2 APAC. We are calling that function with 2 PAC in the bottom. Right now on the stack we are having L2. So because of the 2 PAC, it will come to here n equal to 1. So this condition is not satisfied. Now it will come to here. So now it will call that function with 2 PAC on the stack. 2 PAC on the stack. The return address is L1. Now it will have that one as we are calling that function with 1 PCA. We are calling the function with 1 PCA. So here 1 PCA. So we are currently now we are calling the function with this one PCA. Now here one PCA, here one PCA is written now. So move disk from 1P to A. So this one, so fifth location, fifth point. So this one is here now, right? So move. After moving, then it will return. So return back is to PCA, right? So here PCA, so it will return back to here. Now that one as it will print now. So move disk 2 from P to C. Move disk 2 from P to C. So we are popping out the stack, right? Then here it will print now as move disk from P to C. Then the stack we are having L2. Then once again, then we are having this one. Then we are calling that function with this one. So here once again we are placing the stack is 3 L2, and also now we are placing on the stack 2 PAC. We are placing on the stack. We have to place on the stack is here 2 PAC. Now the return address is L2. So now this one, right? Now here it will go for this location. So this is printing now. So the last one is here move disk one from A to C, right? Then after printing, now it will return. So return to L2. Return to L2. So here what it will do now? Return and return, then it will come out. So this is the way of we are having now. So here we are calling that function with here while going upwards, then you have to do that, and then it will come back, and then it will go back, then it will return back to here, and then it will go. So the order of that writing is here 1, 2, 3, 4, 5, 6, 7. Right? Now the printing is move disk 1 from A to C, move disk 2 from A to B, move disk 1 from C to B, then move disk from 3 A to C, then move disk 1 from B to A, then move disk 2 from P to C, then move disk 1 from A to C. So this is the way output. So using that output, now if you are moving, then our problem is solved. That's all that one. If you are having any doubt, you can write on the command. I will explain later. Okay, thank you.